I'm going to go through section 12.2 today from your textbook. So we're going to substitute in these values for x and see what the outputs are. So I'm going to pull up the graphing calculator. In the graphing calculator, I'm going to change my mode back to function. I'm going to change my table set. So I'm going to hit second function window, and I'm going to change my table set to ask. And I'm going to input my function in here once I clear out what I've got. This is one way to do it. The other way you can is just hit the calculation separate in your calculator. But I want to change my x input. And then I'm going to raise this to the x power. So the reason why I changed my table set to input is because when I come over here to the table now, which is second function graph, I have no values, so I can input 1, and I can see my output is 2. I can input 10, and when they put it in and evaluate it at 10, I'm getting 2.5937. So I'm going to input 100. Then I'm going to input 1,000. Then they want me to input 10,000. 100,000. And then finally 1,000,000. And it looks like the bigger x gets, the y output values are going to like 2.7183. And that's actually e. E is an irrational number just like pi. So if you look on your calculator, let me hit the quick mode. Here's pi on my calculator, and we know it's 3.14. But there's also e on your calculator. It's right above the division sign, and that's what we just approximated. It was a natural number. It was developed by Euler or Euler, depending on how you pronounce it, and it's just like pi. It's just an irrational number. And if you look at the graph here, I've got some exponential functions graphed. I've got the base of 1.5 to the x, the base of e to the x, and base of 5 to the x, and so you can see the different examples. So you can use e for any, and they call it a natural log or an actual exponent, and it can be a base, it can be any number. Like I can calculate, just like we calculate 2 pi, you can calculate 2e. E just represents that decimal representation of about 2.7183 rounding. So to recap, as x gets larger and larger, that y value is going to e as approximations. So we're going to go back to that compound interest formula. And from the compound interest formula, you know that S is your future value, P is your present value, R is your rate as a decimal, K is how many times it's been compounded in a year, and T is your time. Now we've just gone through and shown that 1 plus 1 over x to the x, so instead of having x's I have k's, that goes to e as k gets bigger and bigger. So what they've done is they come up with this new formula, and they call it a continuous interest formula. So to calculate your future value, you take your present value times e to the RT. It's a little bit simpler to use. T is, again, S is your future value, or how much money you have at the end of the time that it's in the bank. R is your rate as a decimal, and P is the amount of money it started in. And let me write down the other formula too, where we had S is equal to P to the KT. So we've got an example here where we got $2,500 deposit at 6% for 10 years. Find the amount of money that you would have at the end of the time when the interest is compounded quarterly, monthly, daily. So this formula right here is what we're going to use for quarterly, monthly, and daily. So when I go through and use this formula for all three of these, my present value, or the amount I'm putting in the bank, is $2,500. My rate is at 6%. My time is 10. And then the thing we're going to have to be careful with, when it's quarterly, your K will be 4. When it's monthly, your K will equal 12. And when it's daily, your K will equal 365 or 360. So I'm going to plug those into the calculator to find the quarterly, monthly, daily, then we'll recalculate that for continuous. So let's pull the calculator back up. So I've got 2,500. I've got 1 plus my rate as a decimal, divided by, let's do quarterly first, and then that's raised to the KT, so that's going to be 10 times 4, so it's going to be 40. So for quarterly, and I'm going to write this on the side so then we can recap it, that's going to be $4,535.04. Math people would round to 5, but the bank's not going to. So we're going to repeat this with monthly, and with monthly, it's the same present value. It's the same rate, so it's 1 plus my rate, but now your rate's going to be divided by 12 because it's monthly. And then you're going to raise it to the 10 years times 12, so that's going to be 120. So for the monthly, I've got $4,548.49 again. So you can see it's a little bit more. So now we've got daily. So we're going to take the 2,500, and then it's going to be 1 plus the rate divided by 365, even though the bank, if it's in a bank, they're going to use 360, and then I'm going to raise this to, and it's 10 times 365, so that's going to be 3,650. So the daily is going to give me an amount of $4,555.07. So now we've got to do the continuous. So on the continuous, it was the beginning amount, and then it was your E raised to the, and then it was how many years times the rate. So it's going to be in the bank for 10 years times my rate of 6% as a decimal. And then the continuous gives me $4,555 and basically 29 cents, 30 if you round. So to sum it up, there's what if it was in the bank for 10 years, compounded quarterly, monthly, daily, and continuously. You can